أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Welcome to the online classes. Today our new topic is speed of sound. Dear students, already we discussed the waves, speed of waves in different mediums, and since sound, it is also the form of wave which is called longitudinal waves or compressional waves. So the only difference is that some waves, like electromagnetic waves, it's not required medium, but for longitudinal waves, which is sound waves, material medium must be required. Without material medium, sound waves cannot be occurred. So when you discuss the speed of sound, so we will must consider some medium, and different mediums have different speed of sounds. Not even medium, material medium, but also atmospheric pressure, temperature also causes the changing in the speed of sound. So the speed of sound can be defined as the distance covered by sound waves in unit time is called speed of sound. Mathematically, V is equal to S divided by T, the simple equation of the speed. So speed of sound can be expressed by distance covered by sound waves divided by time. Different materials have different speed of sound. The speed of sound in solids is very, very greater than the gases. Is very, very greater than gases. In your book, on page number 38, there is a table regarding the speed of sound in solids, solid liquids, only liquids, gases. So in this table you will see some materials, like in solids, aluminium has speed of sound at 0 degrees centigrade. In this case the temperature will keep must constant to compare the materials with each other. Aluminium has a speed 5104 meter per second. Similarly, glass 5550, steel 5050, same. Human bone 4040, pan wood 3,320 meter per second. Similarly, liquids, fresh water at 25 degrees centigrade. Sea water and alcohol, it has different values. Similarly, gases at 20 degrees centigrade. Hydrogen, helium, nitrogen, air, oxygen, carbon dioxide, these all are having different values of speed of sound. So it reflects the discussion that speed of sound varies with the vary of material as well as temperature too. So this is a mathematical simple formula which is used for measuring speed of sound at some constant temperature. We have another expression for the speed of sound as we discussed in the wave. Since sound in the form of wave, so here we also apply the wave equation, speed of wave. We can also apply the speed of waveform, that is V is equal to F lambda, where F is the frequency and lambda wavelength. So if we know these two these two values, we can also find the speed of wave, which is called the speed of sound wave. Similarly, we have another mathematical form. There is another mathematical relation regarding determination of speed of sound. This relation is purely temperature dependent. That is, if there is change in temperature, then we are be able to find the speed of sound. The relation is V is equal to 331 plus 0.6 t, where 331 is the speed of sound at 0 degrees centigrade in gases only. So this mathematical relation, it will not be applicable for the other medium but only gases, and we can find the speed of sound in gases at different temperature, in the same gases at different temperature. So this mathematical formula, it is used to find the speed of sound in the same gases at different temperature. So 331 is the speed of sound at 0 degree centigrade only, in gases only, and T is the given temperature. For example, somebody told me that speed of sound at 0 degree centigrade is 331. So prove that. So if temperature is equal to 0 degree centigrade, then putting the value in equation, V is equal to 331 plus 0.60. We will put 0 instead of T. So the result will be 331 meter per second. If temperature is increased up to 20 degree centigrade, then V will also be increased. So 331 plus 0.6 multiplied by 20. V is equal to 331 plus 12 equal to 343 meter per second. So this formula is very, very helpful to find the speed of sound of a particular space having gas at different temperature. So these are little bit, and these are totally about speed of sound. Now another topic is reflection of sound waves. Already we know that sound is a form of wave, and when a wave is generated and there is some hard medium in front of these waves, then there is a possibility of reflection of waves. So as like reflection of waves, sound can also be reflected. The bouncing back of a sound wave is coming from some medium. Falls on another medium. The bouncing back of a sound wave is coming from some medium, falls on another medium. The bouncing back of a sound wave in the same medium. The bouncing back of sound waves is coming from some medium, falls on another medium in the same medium. represent reflection of sound waves. It is also represented by term echo. Echo. It is also represented by term echo. So echo is a phenomena in which sound waves come back in the same medium from where it generates after falling on another medium. So we hear our sound back in some particular area. This is the living example of reflection of sound. So in this case, the mathematical relation can be expressed as V is equal to 2D divided by T. So for echo or reflection of sound, the distance will be equal to 2D. Let's say this is some hearing and producing sound organ. When wave is produced and it is reflected, by some medium, so it is come back to this position. So the result will be equal to, this is a 1D and this is another D. So the 2D will be expressed as a net distance. So we will use the same formula of the speed of sound, V is equal to D by T. So instead of D we will use 2D because double distance is covered by sound wave. So with the help of this formula we can find the speed as well as the distance of the distance from the distance between the sound source and the reflecting area. And with help of this formula we can also find the speed of sound. Suppose I produce sound and the sound is reflected back to my ear. So if I know the time, if I record the time and I know the distance, then I can find easily the speed, with which speed the sound is produced. So this is a mathematical explanation of reflection of sound. So What are the necessary factors? If I can generate another question, all the reflections can be called, all the echoes can be called reflection, but all the reflections cannot be called echo. So for echo there is some difference, minute difference between reflection of sound and echo. So echo is a phenomena which occurs due to reflection of sound. But how or when echo can be observed? All type of reflections are not echo. If suppose I is producing sound and I am hearing my sound at once, so I cannot differentiate between my initial and final sound, so it is not called echo. For echo, there is some specific distance in which you can discriminate the initial and final, the primary and secondary sound. So there is some difference between the reflection of sound and echo. All the sounds, waves which bounce back into the initial medium is called reflection of sound. Even no difference, even not discriminate between primary and secondary sound. That is produced and reflected sound. There is no difference. You cannot differentiate these two. So this is only called reflection. But echo is the particular type of reflection of sound in which we can differentiate, we can distinguish between produced and reflected sound. So therefore I can say that all the echoes are reflection of sound, but all the reflection of sound are not echo. So for echo, a particular distance should be between source and reflecting medium. Reflecting medium. As we know, we can find this value by equation V is equal to 2D divided by T. This implies 2D is equal to V multiplied by T, and this implies D is equal to V multiplied by T divided by 2. So if I know the speed of sound, I know the time, so the distance should be, for example, if V is equal to 340 meter per second, 343 meter per second at 20 degrees centigrade, this is time, not temperature, this is small t. If V is equal to 343 meter per second at 20 degrees centigrade in time of 1 second, then D is equal to 343 multiplied by 1 divided by 2. This implies 343 divided by 2. So 171.5 to the source in after 1/10 seconds. So I can find the value also. D is equal to V multiplied by T by 10 divided by 2. So V 343 multiply by 1 divided by 20. So 343 divided by 20, it is equal to 17.15 meter. So this is the particular value. 17.15 meter is the minimum distance required for echo at 20 degrees centigrade. So for echo, for reflection is just a phenomenon in which we can observe our sound back. But echo is that phenomenon in which we observe our sound back after 1/10 second. So for this purpose, at least 17 to 18 or 20 meters should be there. At least the distance should be between the source and the reflecting medium is at least 17 to 20 meter. In between these, below this range, you will not observe echo, but reflection will be there. Reflection will take place, but you will not discriminate echo. You will not observe echo. So for echo, the distance should be at least at that position. Not less than, but greater than. Okay, thank you.